All right, we are gathered. All right, I think we will get going. Hi. Thank you for being here, both in person and on Zoom. I'm really glad everyone's here, right? This is the culmination of at least some amount of work. I'm really excited to sort of present the material that we put together for you this week. It'll be a mix of kind of in-person and not in-person talks. Some of the lectures are here, some of them aren't. And yeah, we have a lot of cool stuff to go through this week. So some of you online, some of you in person have attended. This might be your first time, and some of you have attended all of these in some way or another. And so just a little history here. The first year we did variable stars, and that was completely on Zoom. And last year we did multi-messenger astronomy specifically, and that was kind of hybrid. And then this year we're doing transients, and once again we're hybrid. And so the kind of goals that I have, for at least course staff has, and we'll introduce everyone in a second. We're going to try to do, this is really a data science school with kind of astronomy as a motivation, right? That's really how this goes. So the first day we'll be talking mostly about what does an alert stream look like? How do we do stuff with it? How do we filter it? Igor is going to be talking about how we find fast transients. Robert's going to be talking a little bit about how you do like neutrino counterpart searches. But the goal of day one is let's deal with some data. Day two, we'll be talking about Bayesian inference. And folks, some of you will know I'm really like a gravitational wave person at heart. And so when we talk about Bayesian inference, we'll be mostly applying it to kind of multi-messenger sources, neutron star mergers and things like that. But the idea will be we'll be doing fitting, amongst other things. And then more towards the end of the week, we're kind of transition to machine learning in various forms. So we'll do some machine learning on the alert stream, some on some spectroscopy data sets, some other stuff. And so the hope is that, yeah, we're really using astronomy as a tool to, teach some of the data science that undoubtedly many of you are, looking at a variety of topics in your PhD, right? We inevitably will not cover, your PhD topics, right? Some of you are doing, I was about to say TDEs, but we'll hit TDEs a little bit. But I don't know, cataclysmic variables or something like that. We won't do CVs. However, the hope is that we introduce enough stuff that you can, move ahead on the various projects that you're interested in. So I'd say as a kind of as an aside, or as other things that are kind of happening either in the background or in the foreground. So of course, a lot of what we do relies on databases. You'll have some minimal interaction with those this week. We won't be doing too much with high performance computing, although it'll come up some. And the thing I would say is that if there are aspects to these topics that you are particularly interested in, i.e., Michael, I really want to learn how to take some of the Bayesian inference we've been doing and applying it on a computing cluster because I need to analyze, hundreds of thousands of sources or something like that. There's definitely core staff here who can talk to you individually. That's kind of the purpose. Part of the purpose of the afternoons is to be a little flexible here, right? You can talk to us about, here's the project that I really am facing right now, and I know I need to solve for my during graduate school, and we can help you either launch or point you to the right resources. I mean, part of this is work time, right? That's part of the goal. Right. Okay. So, yeah, practical stuff. So as listed on the website, in principle, we are running the synchronous part of the school between around 9 a.m. each day to around 12:30. Now, we'll be a little flexible with that. For example, on Wednesday, I know that our first speaker is going to start talking at 9:30, so we might move this by half an hour, but we'll for sure we'll for sure announce that in advance and post it on Slack and all that good stuff. And the idea is, and those of you who have attended this before, we do a mix of kind of what I'll call science and technical talks in the morning, as well as kind of walking through some of the Jupyter notebooks that you'll be working on. And then the afternoons are really for, group work, working with us, working with each other on problems. And as I said, we're available to discuss and answer any questions you may have, right? And so this is, as I mentioned, this is year 3, right? And so the hope is that maybe even more so than in past years, we'll do our best to kind of if there are topics that you need to see covered, we will figure out how to make it happen. Right. And so the one exception to so that'll be kind of Monday to Thursday. Friday, we're going to end around lunchtime, right? Most people have their flights in the afternoon, some of them even in the morning, right? So Friday is kind of a free-for-all, kind of a mess. Yeah, don't worry about it. Everyone's flying out. It's all good. The GitHub. So hopefully at this point, everyone's seen the GitHub. They've Git cloned it, things like that. If you haven't, please do. Maybe Andrew can post in Slack just the quick Git clone command you should run. This is where we posted the schedule, where we posted the lecture Jupyter notebooks for today. This is in principle where all of the information should be, I would hope. If something is not there, please let us know, right? This is where it should be. Right, and sort of logistically, we'll have, snacks, stuff every morning. There's coffee, tea. We'll be ordering lunch every day, that kind of stuff. So those in person, that's what we're doing. In terms of activities, so on Tuesday, the plan was for those interested to go to the Bell Museum and a planetarium show, which is just on the St. Paul campus. You take a short bus ride. On Wednesday, there's a survey being built here called Turbo, which is an array of small aperture telescopes to do sort of wide field imaging, ZTF light, I would say. And the graduate student who runs that project, or kind of the lead instrumentalist on that project, was going to lead a tour on that on Wednesday afternoon. And then on Thursday, we were planning to have some kind of conference dinner type thing. We're still kind of figuring out exactly how that'll work, but that's yeah. So those are the afternoons. This afternoon, is just kind of, we're here, we'll figure it out as we go. I mean, some people are still arriving and all that stuff. So there you go. So for those in Slack, do this in the chat as well. Maybe, but yeah, on Slack. But maybe we'll start with course staff here. So basically those in the back. So I am Michael Coughlin. I'm an assistant professor here. I'm nominally in charge of the summer school. My preferred pronouns are he, him. And a silly fact about me is I love talking to the squirrels and the rabbits on campus. If it's kind of hot, it's a little hazy. I'm sorry. This week's a weird week for Minnesota. Usually it's not as nice as it is sometimes during the summer. But yeah, we're glad to have you here. So maybe we'll start with, Andrew and K. Ryan and Light. Can you kind of wave? So we'll start with the staff kind of people.
Hello, everybody. My name is Andrew Coughlin. I'm actually from Wisconsin, and I work here with Michael. I'm going to be a 4th-year PhD student. And let's see, a silly fact about me. I love craft I guess you should unmute
Yourself
yourself.
here. Silly fact about me, I love Kraft mac and cheese, but only the ones with the shapes, like the little characters or whatnot.
So, hi, you muted.
I'm unmuted, so.
So, hi, so I'm a second year PhD student at Liverpool John Laws in the UK. I'm here to be a teaching assistant, and I kind of work on supernova at the moment with ZTF. A funny fact about me is that I'm lactose intolerant, but I love cheese anyway. So,
Hi all, my name is David. I'm from Bulgaria. Silly fact about me is that I watch anime.
Hi everyone, I'm Ian. I'm from Chicago, and yes. Hi, my name is Seiji Toshikage from Tohoku University in Japan, and I'm researching about rapid transients with the telescope. And silly fact is, this is my first travel overseas alone, so I'm really nervous now. Please talk to me freely. Okay, nice to meet you.
Hi, I'm Igor Andreoni. I will be lecturing here. I'm based at University of Maryland and NASA Goddard. I do fast transients, multi-messenger astronomy in general. Silly fact about me, I packed half my bag with fishing stuff to come here, but I couldn't board the fishing poles, so probably I'm gonna go buy some these days and try out the Mississippi River.
Hi everyone, my name is Amanda. I am from Denmark. I am on my master's doing Earth and Space Engineering, so rockets and shit. My pronouns are she, her, and a silly fact about me is that I have 4 brothers. Yeah, so I am the baby of the family. Yeah.
Hi, my name is Alan, and my pronouns is she, her. I'm from Canada, Vancouver. Oh, I see. Canada, Vancouver. And also, yeah, I research solar system, and what was a silly one. I really like a game called Mahjong, so I made a contest, and yeah.
Thank you. My name is Narikazu Higuchi. I'm from Japan, Tokyo Tech University. So I have little difficulty on the communicating English, but please talk me freely. Thank you.
Hi there, my name is Chris. I'm a 3rd year student at Pitt, and my pronouns are he, him. And a silly fact about me is I love to read, and proud of the fact that I can read a book in less than a week. It's been a good accomplishment.
Hi everyone, my name is Simran. I am first year, because soon going to be 2nd year student from University of Michigan, Ann Arbor. My pronouns are she, her. And a silly fact about me could be that my interests are always changing. Sometimes I love to watch web series, anime stuff. Other times I love to read books, and most of all, I love to be outdoors in the nature.
Hello everyone, I'm Kirti, and I'm a rising 2nd year student at Carnegie Mellon University. And a silly fact about me is that I watched Naruto Shippuden like 2 times and planning to watch the rest.
Hello, everyone. I'm Tomas. I am a rising 4th year at Carnegie Mellon. I do transient astronomy multi-messenger. And a fun fact about me, is that I actually once competed on American Ninja Warrior in this city.
Oh, wow.
Hello, I'm Adrian. I'm a rising third year, they, them pronouns. I'm at UVA and I work with Tyler Pritchard. I think you might know him. My silly fact is that I'm 80 years old on the inside and that all I do is mimic my cat. Yeah.
Hi, I'm Natalie. I'm rising second year at UC Berkeley. I'm from California, near the Bay Area, and fun fact about me is I went to online school before it was cool.
Hi, I'm Haley. I'm a rising second year at the University of Illinois Urbana-Champaign. Preferred pronouns are she, they, and my fun facts are I've assembled 5 computers and I'm 50% of the way through One Piece.
Put this way.
Okay.
For me to go around.
Hi, everyone. I'm Connor. I am a rising third year at Rutgers University, pronouns he, him. A fun fact, I don't know how fun it is, but I'm actually completely colorblind, like monochromatic.
Keep that in mind when you make a plot.
Yeah.
I will find you.
Hi, I'm Jacob. I'm a first year PhD student at Liverpool John Moores University. I work in supernovae. I guess a fun fact about me is that the first thing I intended to do when I got to the US was try McDonald's. I've been here for 2 weeks, haven't managed it yet.
We'll get there.
Hi, I'm Shubham. I'm doing my master's in ICER Thiruvananthapuram in India. My pronouns are he, him. And a fun fact about me is that my online friends call me Bread, and I'm quite used to it, which makes conversations at home kind of interesting.
Hi, everyone. I'm Divya Mishra. I'm a rising second year at Texas A&M University. My pronouns are she, hers. And a fun fact about me would be that I have cried watching all the Pixar movies.
So, thank you, everyone, for doing that. Right, and I mean,
I'm gonna mute this one. Do you want
Yeah,
to mute yours?
yeah.
And I need to probably reshare, right? And I hope folks, oh, no. Well, my screen's done. Let's do that. What happened? Okay. Okay.
Yeah, so I said Slack a few times, please do use it. So even those in the room, right, if there are questions that you're wanting answers to, like, during the talks or even, during the Jupyter Notebook session, of course, call us over and ask it, but there will be value in kind of, also posting your question in Slack so we can at least keep track of what's been asked, who's answering what, all that good stuff, just because, we have folks online too, right? So please do be active. Have we made a day one Slack channel yet? Has that happened?
I know.
Could you, if not, okay. Yeah, so ask for help early and often, especially from each other. Experience shows, so some of the notebook content is new, some has been modified from previous years, but the truth is none of it is like polished or, this isn't a class, right? This is a summer school with the idea that, we are hoping to introduce you to material that, again, will help you during your graduate school career. And, a lot of what we're working on, or a lot of what we're, share this screen? Oh.
You'd think I'd be better at Zoom at this point, just.
Todd, is it better now? Thank you, Gord. Yeah. A number of like the packages or the software toolkits, it's stuff that, we and graduate students in the room are still developing, right? I mean, within ZTF, things are moving all the time, and so there's going to be bugs. The documentation won't be completely complete. Some of it might just be broken, that kind of stuff. This is all, this is kind of part of the research experience. And so we are in principle working on stuff kind of at the edge of the research horizon here, right? This is stuff that we're writing papers on and still doing today, all this stuff. And so this is a plus, pluses and minuses. One, it's good that we're not just, doing stuff that was, let's say put together a decade ago, and therefore, there's textbooks on and all that stuff. That's nice for sort of a nice clean class, but it has the obvious downsides of, not everything's going to be perfect. So please work together, work with us, have good cheer, let's say, when or I don't know, empathy or sympathy or something, I don't know. But do ask for help and so on. And we want this to be fun, right? There's no we will take attendance just to keep track of who's here and what's up and that kind of stuff, but you are also busy graduate students doing your own stuff, right? You're gonna be like, yo, Michael, I got telecons, tomorrow morning. I'm not gonna be here for this lecture, can I, watch it on, YouTube later, or can I talk to you later about it or whatever? The answer is always yes, right? I mean, there's no expectation that you must be here from 9 to 12:30 and then in the afternoon. As I said, we, this is just flexibility, right? Okay. Yeah, so this is the plan. It's posted on Slack, or sorry, it's posted on GitHub. Yeah, and I don't think it's important. Yeah, and some code bases. Yeah, we'll move on. Yeah, so I'm just going to say a few words. Igor is going to get up here in a minute, but just to say kind of why we're here, right? We are, we're working on the Zwicky transient facility. Many of us in the room, many of your PhD projects, touch on, optical survey data from ZTF. What is ZTF? If we look at Palomar Mountain here, we have the 48-inch. ZTF is a 50 square degree camera on the Palomar 48-inch. It has been, the survey has been running since 2018. At least currently it is funded through, I think it's September 2024, right? And so, and then there's plans for going beyond. On the same mountain, and again, we'll look at data from this system too, is the 60-inch, which has the SED machine on it. This is a low resolution spectrograph and imager that's doing, amongst other things, bright transient classification of objects that ZTF and other surveys find. And then the 200 inches on the same mountain. The one thing I want to highlight, and you can ask some of my graduate students about, we just put a new version of this SED machine, this low resolution spectrograph on the KIT Peak 2.1 meter. It started taking some data. There's there's some opportunities here to also take a look at some of this data for those of you who are interested. And so I think this is a cool time for all of you to be in graduate school, about to be in graduate school. Sounds like some of you are about to finish graduate school. There's a ton of experiments either already online or coming online that have data, some of it public, some of it, kind of public, some of it private. And a lot of PhDs, I expect, over the next decade will really be about, can I exploit these data streams that I have access to? This is in opposition to, when I was in graduate school, I was maybe kind of one of the last generations of, I go to a telescope regularly and I bring an instrument, or I go and, take, a bunch of spectra, classical observing of a bunch of stuff and, write an essay about it. But more and more these days, what, astronomy looks like is I'm going to take advantage of, survey data on the sky and combine it perhaps with, data from other surveys, either tests, or if I'm interested in multi-messenger stuff, ice group for high energy neutrinos, LIGO Virgo / Coughlin for gravitation waves, and, perhaps getting spectroscopy, in near real time using robotic telescopes. I know a number of you kind of have PhDs at the edge of these optical surveys and, sort of real time follow-up observations. And this is a fundamental transition, right? Because in many senses, it becomes about, can I figure out how to exploit these large data sets for the science goals that I have in mind, as opposed to, I'm going to write a, observing proposal, go to a telescope, do a thing, right? And so, who can do this best? Who can do this fastest? It's, this is kind of what graduate astronomy is becoming. And so it's important to understand how to, one, access the data sets we're talking about, but two, understand what's inside, apply those Bayesian inference algorithms to apply those models for TDEs or whatever you're interested in, to apply machine learning algorithms to be able to pick out the sources that I care about amongst these, ZTF puts out something like 1 million new alerts per night. Rubin will be an order of magnitude larger than that, right? This means that, the days of astronomers, scanning stuff by eye is mostly ended, right? It's mostly, can I write algorithms to identify the kind of objects I care about? And then, yes, graduate student, looking at the data to understand, oh, this looks really interesting. I'm going to do something with this. And so, what's kind of the landscape of astronomy these days? There's a wide variety of surveys out there. Most with some amount of public data, right? So some of you, I'm sure, have heard of Assassin, which is an array of, mostly small aperture telescopes led out of Ohio State, which covers both hemispheres. They have really nice catalogs available online. A little slightly larger aperture, so Atlas and Pan-STARRS. So Atlas now is a worldwide network of small aperture telescopes. There are now 2 Pan-STARRS, both on Haleakala. We have ZTF, which, as I mentioned, is on Palomar. For example, Atlas has a force photometry service, just like ZTF does, that you can get access to access their data sets. Looking towards the south, so Black Gem, I think they're commissioning now, but they'll be observing routinely, presumably very soon. And Rubin, I think 2025-ish. You see the emails, I'm not really sure, can hardly keep track. But the point is, there's a proliferation of data sets that are now available to everyone in some form, right? As I said, different observatories have different access rules, but it's a real question, like, how do I get access to both ZTF and Atlas data to apply to this particular object I care about, right? Writing algorithms, query APIs to get data from those force photometry services and everything. We'll have some of that in the notebooks. We have, for those of you who are interested, we can of course talk about that. And so, as I mentioned, sort of the way that astronomy is done, it's changing now, right? So the kind of the typical way most people think about things currently is, I'm going to detect things photometrically. I'm going to take ZTF. I'm going to take images on the sky. I'm going to find my supernovae and TBEs of kilanovae and so on. And then I'm going to take a larger aperture telescope and get spectroscopic classification. This is fine, but this works okay for surveys, on kind of meter class telescopes, let's say ZTF, Atlas, Pan-STARRS, and so on, where objects are relatively shallow. And so you can use your sort of 4 meter, ish size telescopes to get spectroscopy. But with Rubin coming online, not really going to be the case anymore, at least as much. I'm going to have, this multi-band survey that's going to go down to, 24th, 25th magnitude. Most science coming out of Rubin, you're going to have to figure out how to do just with the time series itself, right? Which means that you're going to be getting large samples of relatively faint objects. For example, you're a person who, is working with Raf Margutti on LF bots. For example, you're going to have to figure out how to, fit models to mostly fading things, right? Much of the analyses you'll do will be statistical. You're going to be doing your Bayesian inference, maybe some machine learning to classify some things, and perhaps then you'll figure out, how to, identify the handful of things that you can use your, really precious resources, your, access to kind of 10-meter class things to get a spectrum of. But again, almost all of this is really data science, right? These are data science tools applied to astronomy, and this is really, at least for many areas of what I'll call, time domain, right? We're here in, year 3, so we're doing transients. This is really what the field is becoming. Okay, and so to just say something about ZTF. Half of all ZTF data goes immediately public. There's an alert stream. We will be dealing with that alert stream this week. The other half is private, but comes out in kind of later data releases. And so this is, we'll be working with ZTF. And we'll be touching on, I would say, like a lot of kind of the data processing of ZTF, but kind of different aspects of it. Light curve fitting or machine learning, toolkits that we apply to those images. These are things that you'll see and work on this week. And kind of the final thing I'll say, right? This is called the ZTF Summer School, but the truth is, this is really, kind of a astronomy data science summer school, right? Like I want to sort of emphasize the point. ZTF it's kind of an aside here, right? Like we could have called it Atlas or BlackGen or whatever, and the same tools would have been applied, right? There's very little about ZTF that is, specific. It's just a bias because the people who are leading the talks and so on, they're ZTF people, but everything that we're talking about is one, being applied in some form on these other surveys, and of course will be applied for Rubin, right? And so given that some of you are, kind of first and second year PhD students, and that alert stream will dominate here in the next few years, this is, really what you need to be looking ahead to. ZTF is really kind of Rubin light. There's, the scales are slightly different. You get more epochs with ZTF, but it's, much brighter and so on. But, as I mentioned, like, a lot of this stuff that we're learning is basically the same. And sort of to close, right? Why are we doing this, right? So time domain is a field, right? It's just too dynamic to kind of use old techniques. I'm just going to sit and try to, as a human, scan all of this data. We're really geared towards applying data science tools to enable, real-time follow-up of things. And yeah, the hope is that we'll introduce you to at least some of the algorithms that we're thinking about, we within ZTF, to make this happen this week. And yeah, so thanks for being here. Look forward to working with you this week. And unless there are people they don't have any questions, I guess, but otherwise we'll just sort of get rolling with actual content. Okay, so I'm going to invite Igor up, who's our first speaker, and yeah, let's.
Only after we give a round of applause to Mike.
Oh, okay.